Hello everyone, welcome back to my channel. So in this video we'll learn some of the important properties of convolution. Okay, some important properties or formulae of convolution. Okay, right, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So first of all, when a signal, unit step signal u of t is convolved with itself, then the resultant will be ramp signal. Okay, so resultant will be r of t. So this we can also prove using Laplace transform. So this is 1 by s, and convolution in time domain is equal to multiplication in s domain. So it will be 1 by s into 1 by s, which is 1 by s square, whose inverse Laplace transform is t into u of t. T into u of t is again a ramp signal. Ramp signal. Okay, so this can be easily proved using Laplace transform. And second, from impulse function. If you have an impulse function in one of the convolution signal, that is del of t convolved with x of t, del of t convolved with x of t is x of t only. Okay, so if del of t minus t naught, that is shifted impulse, is convolved with x of t, then it will be x of t minus t naught. Okay, so this is the property of impulse function in convolution. Next, if you have two signals x of t and y of t, okay, so consider two signals x of t, h of t and y of t. So where h of t is the impulse response or in system, impulse response of the system, right, y of t is the output of the system and x of t is the input of the system, then property A, x of, so what we have is x of t convolved with h of t is equal to y of t. We know this. Okay, so the output is given by the convolution of input and the system. B, if there is shift in x of t, that is t is x of t is shifted by alpha, and similarly h of t also shifted by some amount beta, then y of t is shifted by t minus of alpha minus beta. Okay, t minus alpha minus beta, right? Okay, so just remember this property, very important property. Okay, so we'll solve some problems also regarding this. Right, next, d by dt of x of t convolved with h of t is equal to d by dt of y of t. So whatever operation you perform on x of t, the same operation will be performed on y of t if the system is LTI system. So the condition here is, if the system is LTI system, then whatever operation you perform on x of t, the same operation will be operated on y of t also. Next, x power m into t convolved with h power n into t is equal to y of m plus n in t, where m comma n are order of differentiation. Order of differentiation. Okay, that means if x of t is differentiated one time, convolved with h of t is also differentiated one time, okay, then you have to differentiate y of t two times, d square y of t by dt square. So the convolution between the signals d by dt of x of t, now the signal is not x of t, it is d by dt of x of t, and our impulse response is also differentiated by one time, that is d by dt of h of t, then then the output should be differentiated by two times. Okay, so this is what the formula here is. Next, fourth one, if the area under x of t is ax and area under h of t is ah, then area under y of t is the common area, that is ax into ah. Ax into ah. Next property, the last one, is x of alpha t, that is scaling property, into h of alpha t is equal to y of alpha t. If you scale by alpha x and if you scale the same by parameter alpha h of t, and there will be same scaling in the output also by same instant. Okay, sorry, 1 by mod alpha, 1 by mod alpha into y of alpha t. It's not y of alpha t, so it is 1 by alpha. So this is helpful when you are finding for alpha is equal to -1. So if you have x of minus t convolved with h of minus t, then the resultant is y of minus t. X of minus t convolved with h of minus t is equal to, just substitute alpha is equal to -1 in this expression. So x of minus t into h of minus t is equal to 1 by mod 1. 1 by mod of -1 will become 1 only, so it is not required to write. So it will be equal to y of minus t only. Okay. Similarly, if you have x of 2t, x of 2t convolved with h of 2t is equal to 1 by 2 into y of 2t. Very simple. Okay, so this is how we can apply these formulas. Okay, so out of this, every formula is important in order to find the convolution. Okay, so next, if you are asked to find the convolution of following signals using properties of convolution. So now we'll see examples by using the properties of convolution. Okay, so in the first problem, he has given x of t plus 5 into del convolution with del of t minus 7. So we know that x of t minus t naught convolved with del of t minus some ta is equal to, the convolution is y of t minus t naught minus ta. So that is, sorry, x of t minus t naught minus ta, because convolution of x of t with del of t is equal to x of t only. Okay, so now shifting property also can be applied. So then x of t plus 5 convolved with del of t minus 7 can be written as x of t plus 5 minus 7. So here t naught is going to be minus 5, t naught is minus 5, and ta is going to be 7. So x of t minus of minus 5, t minus of minus 5 is plus 5, minus 7 is minus 7 only. Okay, so this will be x of t minus 2. Okay, this is the answer. So if you are given with a signal like this, you can use the property of convolution property of impulse. Right, for this question, second question. So this is for A. Now for B. So what is the impulse function given there? So how can we write this function in the standard form? So y of t is equal to convolution of first signal convolved with the second signal. So how can we write this signal? So this signal is u of t can be written u of t minus 1. So shifted by 1, u of t minus 1 can be written from 1 to infinity. U of t is from 0 to infinity. So similarly, u of t minus 1 is from 1 to infinity. Similarly, u of t plus 1, u of t plus 1 is from minus 1 to infinity. So minus 1 to infinity. Okay, so if you take the difference between these two, so it will extend from minus 1 to 1, and from 1 both values are equal to 1. So suppose from 2, if you take for 2, so both values are 1, so 2 minus 2, so at instant 2 it will be 1 minus 1, which is equal to 0. So the difference between these two will exist from minus 1 to 1. That means this signal can be written as u of t plus 1 minus u of t minus 1. This is from basics only. Okay, just by using shifting property. Okay, and then there are two impulses, one at 3 minus 3 and 1 at 3 with an amplitude of 2. So what can we write here is, so 2 I'm writing outside into del of t plus 3, del of t plus 3. Del of t plus 3 means at t is equal to minus 3. T is equal to minus 3 have an impulse of amplitude 2. So this one. Okay. Plus del of t minus 3. Del of t minus 3 is t is equal to 3. So t minus 3 is equal to 0. So t is equal to 3. So you have an amplitude, if you have an impulse at 3 with an amplitude of 2, because 2 you have multiplied. So this is the signal. So this is your y of t. So y of t is equal to this. So y of t is equal to 2 I am writing outside. So what can we write? U of t plus 1 minus convolved with, so this convolved with the first one, del of t plus 3. Next, this signal is convolved with this signal, plus u of t plus 1 convolved with the del of t minus 3 minus u of this signal, the second signal with first in the second signal. So u of t minus 1, this signal with convolution with this signal, convolved with del of t plus 3 minus last one. So this and this, u of t minus 1 convolved with del of t minus 3. So how can you write y of t in standard form? So y of t is equal to 2 into u of t plus 4. This becomes t plus 1 plus 3. Okay, so using this property only, t plus 1 plus 3. So t plus 4 plus this becomes u of t plus 1 minus 3, so it becomes t minus 2. T minus 2. Right? So t minus 2 plus, minus, this becomes u of t minus 1 plus 3. T minus 1 plus 3 is t plus 2. T plus 2, and this becomes minus u of t minus 4. Okay, so this is your output signal. Understood? So just using the property here. So what is the property? U of t minus t naught convolved with x del of t minus ta is equal to u of t minus t naught minus ta. That's all. So using this property, so in this case t naught value is, so this can be written as u of t plus 1 convolved with del of t plus 3. So t naught value is minus 3. T naught value is minus 1, ta value is minus 3, so it will be u of t minus, t naught is minus 1, so minus of minus 1 is plus 1, and ta value is also minus 3, so minus of minus 3 is plus 3, so it becomes u of t plus 4. So that is what I have written here. Similarly you can do for remaining and you will get the answer like this. Okay, now see the last one. So how can we write last one? So y of t is equal to same, this is same, u of t plus 1 plus u of t minus 1 convolved with, now the second signal, how can we write the second signal? Now second signal is also u of t, it is not r of t, so it is not del of t, so it is also u of t. So how can we write this signal? So it starts from 3, so u of t plus 3 minus u of t minus 1, minus u of t minus 1, because u of t plus 3 will starts from minus 3 and ends at infinity, and similarly minus u of t minus 1 starts at 1 and ends at infinity. So difference between these three will be from minus 3 to 1. So that is what the signal we have, so we can write like this. So this can be written as u of t plus 1 convolved with u of t plus 3 minus u of t plus 1 convolved with u of t minus 1. Okay, so u of t minus 1 plus u of t minus 1 convolved with u of t plus 3 minus u of t minus 1 convolved with u of t minus 1. So from the first one, u of t plus 1 convolved, so u of t convolved with u of t is r of t, so it will be r of t plus 4. Okay, same, t minus t plus 1, t plus 3, so t plus 4, and it will be minus r of t plus 2 minus r of t plus r of t minus 2. So this is your output. Okay, so let me take one more slide. I'll tell you an important point here. Okay, so I hope you have understood this. Okay, so you just follow the same rule and you'll get the answer like this. Okay, so we have just seen convolution of two signals here. So 1 minus 3. Okay, so convolved with minus 1 to 1. So we have got the answer as r of t plus 4 minus r of t plus 2 minus r of t plus r of t minus 2. Okay, so this is what the answer we have got. So if you draw this signal, so it starts from minus 4. So from minus 4 there is a ramp signal, so it extends up to minus 2. Okay, so from minus 4 to minus 2 there is no problem, so because there is no other signal. So at minus 2 it starts with a negative ramp. So here the positive ramp with slope is equal to 1, and at t is equal to minus 2 it is getting a negative ramp. So positive slope and negative slope cancels off, so slope will be a constant. Like this. Okay, so I am telling you how to draw this signal. Next, there is a negative slope at 0, because r of t is a signal which starts at 0. Okay, so until this 0 occurs, this positive slope and negative slope cancels each other and the slope is going to be 0. So it will have a 0 slope like this. And then when t is equal to 0 arrives, this signal will be in active state, so this becomes added. Okay, so there will be a negative slope like this. Okay, up to 2. At 2 there is again a positive slope, so negative slope and positive slope, which makes the slope is equal to constant. So the constant slope, which is equal to 0. Okay, since it is increased up to here and then you have got a negative slope, so you will have a constant slope at that amplitude only. So from r of t you have decreased it to 2. Okay, so beyond 2 also it will go like this. Actually r of t goes like this. Okay, because it will have a negative amplitude, but at 2 you have a positive slope, so positive and negative slope becomes 0, so it will continue in this state. So it will be the output, which is y of t. So the important point which you have to note here is, so if you observe here the time period. Okay, so time period here is going to be 4, 1 minus of minus 3. So 1 minus of minus 3 is the time period. So time period is 4 and here time period is 2. So the statement which you can write here is convolution of two unequal rectangular functions. These are rectangular functions. Two unequal rectangular functions. Okay, two rectangular functions results in trapezium. Okay, so this is the important point which you have to remember. Similarly, I'll tell you one more concept also, and I'll solve this question in the next video. Okay, so if you want you can refer next video also. That is the concept of differentiation. Through the concept of differentiation I'm going to prove that also, but I'm telling you the point here only. So convolution of two equal time period, two equal time period rectangular functions, result in triangle. Suppose if you have two equals, so 1 to minus 1 convolved with minus 1 to 1, so the resultant is from Resultant is a triangular function from -2 to 2. So the sum of the lower limits, -1, which is equal to the sum of the lower limit here. Okay, so sum of the upper limits, 1 plus 1 is the upper limit here. Okay, so if two equal, if you want you can check for this also. You can solve for like this, and you can draw the output y of t. You will get the same function here. So -2 to 2, it will be this. Okay, so the important point here is convolution of two equal time period rectangular functions results in triangle, and convolution of two unequal rectangular functions results in trapezium. Right? Next important point here is convolution of two causal signals. Two causal signals is also causal. Okay, suppose u of t minus 2 convolved with del of, suppose t minus 2. So from the property we know that it is equal to t of t minus 4. Here t naught is 2 and ta is also 2. So u of t minus t naught minus ta. So it will be t minus 2 minus 2. So it will be u of t minus 4. Yes or no? So u of t minus 2, how can you draw this? So it extends from 2 to infinity, u of t minus 2. Similarly, convolved with del of t minus 2 is also a causal signal, because it lies for only positive value. So this exists for positive value, this exists for positive value, and the resultant u of t minus 4, it starts from 4 and ends at infinity. So this also exists for only positive values. So if a signal is existing for only positive values, then we will call that signal as causal signal. So convolution of any, so this is a causal signal and this is also a causal signal, and convolution of this is also a causal signal. Okay. Similarly, convolution of two anti-causal signal is also anti-causal. Okay, so convolution of two anti-causal signals is also anti-causal. Suppose u of t plus 4 convolved with del of t plus 2 is equal to u of t plus 6. So this is anti-causal, this is also anti-causal, defined for negative values. So u of t minus t plus 4 exists from -4 to infinity. -4 to infinity, that is existing for only negative values. Del of t minus 2 exists at -2, which is for only negative value. And u of t plus 6 exists from -6 to infinity. So this is anti-causal, this is anti-causal, and this is also anti-causal. A signal is said to be anti-causal if it exists for only negative values of time. Okay, so these are the important points which you have to remember. Okay.